Okay, so do you guys have questions from 6-2's homework?
Yes.
The last half.
The last half? Okay. So
I was fine, except for 47.
It was more like just, I think I just needed a reminder. Or not a reminder.
Actually, no, I
You
think
just
it'd be
need
okay.
a walkthrough for every single problem.
It was
okay,
because
so just give me a number.
I
We'll
think
start
it was
there.
47.
47.
that's the really long one.
Okay.
Or just like one of those ones. Cause
It's got like a
I got all the way up
chart.
to 43
pretty
with
chart.
the homework, and then the other ones I got confused.
Graph each polynomial function on the table, then copy and complete the table. Describe the end behavior of the graph of each function. Oh.
Now I understand how to do this. Okay.
Well, that's good.
Because like when I first looked at the lesson, I was like, "What is this? Like, how do I do this?" And later on, I was like, "Oh, okay, it's not so bad." Okay. But Desmos is much easier than graphing calculator because it's all like right there, you know.
Right, so what is all this about school getting out at like 4:30?
Well, it's because lunch is not 4:30, it's 4:10. But it's because lunch is longer. Because
Why?
Because they have all the selling
That's
stuff. I know, so they're having
stupid.
lunch longer.
Well, I'm going home, so.
So it's 30 minutes or something.
Wait, what?
Lunch is longer today.
I remember they did that last year.
So
like they'll
for
push back
like my
classes.
history class, instead of getting out at like 2:10, it gets out at like 2:30. So then chemistry starts at 2:50, and then I don't get out, so it'll be 4:10 or like that.
Where was this communicated?
I just had a classmate tell me like last night, but
I
like,
was-
you know all this stuff
somebody
downstairs,
added
how
me
they
They
sell
do
all
that
that
text
stuff.
chat.
Yeah.
They're doing like a longer lunch for like they're calling it a Christmas party, but it's not like a party. It's just like since they're doing like pictures and selling stuff and buying stuff.
They need to get more money. Just kidding.
So they're having like a 30 minutes longer on lunch.
Well, I'm not making my class go longer. My class will
No,
be
the
done.
all the class times are the same.
No, I mean my class will end at 3:40. That's it. Bye, kids.
Class just starts later.
Well, whatever time they get there is when they get there, and then they're leaving at 3:40 because this was not communicated to me, and I have a second job. So it probably should have been communicated to me.
Oh yeah, I didn't even know about it until like.
I don't think the kids will care.
Oh no, like okay.
I remember, like, yeah, last year I had to call my mom, like, in class. I was like, "Mom, we're not ending for another 30 minutes." She got really mad at me. But it's okay.
Why did you? That's just.
You should have
all
left.
worth, huh?
You should have been like, I have to go. It's a family emergency. Bye.
And gone up and gone.
You know what? Uber is actually everything. Like, I took an Uber to Target this morning. It
You
was
did?
pretty great.
This
Yeah.
morning?
How did you
This
make it to
morning.
Target this morning but before class? Wait,
Because-
is math your first class?
Yeah.
Oh, okay. I'll say, wait, how did you make
No.
it? I was like, that's impossible.
I made it to Target and I got a sandwich and
That's amazing.
I hung out.
Okay.
Yeah, it's
So-
pretty great.
Oh, I should have.
Graphing functions. Did you guys graph these in your graphing calculators or Desmos?
Yeah,
Yeah.
Desmos.
I still don't have one.
Did you do Desmos?
Just use Desmos.
No, I did not.
Do you have your phone?
No, not with me.
Really? That's cool. I just expect teenagers to always have them.
Do you have
I need
a
it,
flip
otherwise
phone?
I'll get abandoned.
No.
You don't have any phone, huh?
He just doesn't have his phone with him. He has an iPhone.
No, it's broken. It's been broken for a long time, right?
Like, what? 3, 2? No, it's only like a month.
Oh, okay. Actually, I'll do Desmos on my laptop because it's big.
I like it on my phone. It's just simpler because it's like.
The buttons are kind of messed up on the phone though.
No, they're not.
I think it's easier to just type
It's
it.
simpler.
So I'm just going to start going over this. Okay. Because this is odd as a degree, it's cubic, and the leading coefficient is negative, we know that as x approaches positive infinity, it will go down. And as x approaches negative infinity, it will go up. Because it's
Because
been flipped.
the leading coefficient is negative?
Right.
Or, okay.
Because it's an odd function, they're going to go in opposite directions. And because the leading coefficient is negative, they're flipped. so that x becomes more positive, y becomes more negative.
Because it's an
Mhm.
odd function, meaning it's to the third degree rather than an even degree.
Right.
Okay.
And as x becomes more negative, y becomes more positive, and so y goes up. And then here, leading coefficient, odd, and it doesn't even matter what the rest of it is for end behavior. So, and leading coefficient negative, degree, odd, so same exact thing. Down, up. And then here, cubic, negative coefficient, down. And what do you know? Cubic,
Same
we're
thing.
looking for the highest degree, so it doesn't even matter if there's
Negative
something else there.
Mhm.
Yep, down, up.
Okay, that's not bad at all.
And then you do the graph
Yes,
thing.
Okay, so I know there was a problem actually that I was a little bit confused by.
Okay.
That was like use what you know about the end behavior of a graph and then pick the graph that matches the equation.
Okay.
I graphed it
Okay.
because I was a little bit confused and there weren't any graphs that matched the equation.
Do you know which number it is?
No.
That would be
Wow.
helpful.
But there was a graph that matched the equation in end behavior. There was only one. So
Well, it's
it's like even though it's not perfectly accurate to the equation, would you just use the one that has matching end behavior because it was a question about end behavior?
well, you know what? I think you're talking about one of the problems 49 through 52, because that's what it says to do, and it gives you 4 options. If you look at these graphs, they don't have any kind of scales on them, so they could be highly zoomed out or highly zoomed in. So it's probably an accurate graph. It's just with a different view of what's going on. So you would only look at the end behavior.
The one I was looking at would have like kind of it went up and then it curved off and was flat for about 6 or 8 units.
I think I remember seeing that.
Yeah, and
Which,
then
if
it
you
curved
zoomed
off
out-
and went down.
Would look like that if you zoomed out enough.
Are you
Yeah.
sure? Because wouldn't it be super skinny if you zoomed out enough?
Not necessarily. I mean, which one are you
Because then it
talking
wouldn't be a
about?
polite
It's
curve.
really hard
Okay,
for me
wait,
to say.
what- Can I don't have my book out.
Well, that's
So this is what page are they on?
334.
334?
yeah.
It was B, whatever the one that had an answer to B.
50 something.
51.
51.
I got D.
Oh right, because we were only supposed to do one of these, so
Oh, I don't
did
know.
it end up being 51?
I just 51 corresponds to B. I can tell just by looking at it.
Okay, wait. So negative.
I think we're supposed to do
X to the
51.
fourth.
That's the next one.
Plus
Yeah.
1.
Wait, did we end up doing 81? Because I didn't.
No,
I
it didn't line up.
Yeah, no.
Okay, so this is what
I
it
do my
looks
best.
like, right?
Sometimes I make mistakes.
I
Yeah,
got
that's
so
fine.
confused.
But then, like, if you zoom out,
Did you still do it?
Oh, it looks like a parabola.
it gets really skinny, right?
But it still looks like a parabola. I mean,
guess.
you don't know. What
So I
if
mean,
you
it doesn't
zoomed out-
match up perfectly, but
Well, you can zoom out differently on the x's and the y's. You're maintaining that same ratio.
oh, okay.
So it can still look like this from a certain image.
If you skew the original ratios.
Well, you're thinking about it as though that is the only correct way, and if you change this way and kind of corrupt it, then it can look like this. But that's not the only correct way. That's just one way. What if we're...
Wait, so one equation has multiple graphs?
No, if you zoom out enough, that's why we're talking about the end behavior. The end behavior will look the same.
Right.
If you're looking at extremely high values of x and extremely high values of negative x, extremely low, then the graph behaves the same as every other graph with the same coefficient, leading coefficient, and
Yeah. So the question
degree.
is all about end behavior,
right.
whether the graph is accurate or not.
Right, we're not
This is
thinking-
the only one that has both ends of the
Down,
parabola going down.
Mhm.
So that would be the correct answer.
Right.
All right, I got that one.
Okay.
So I just wanted to make sure because that seemed I was so confused for a while. I was like, oh wait, it's just end behavior.
Okay, what other one? Or is there any more? Can we move on to 6-3? Yes. Okay, 6-3 it is.
I just gotta finish writing the graphs for these. Super quick.
Okay. Adding, subtracting, and multiplying polynomials. Yay!
Yay.
This is the same stuff as with quadratics in chapter 5.
Oh no.
Same rules, except now our polynomials are not limited to a degree of 2. Okay? Cool. When you have a degree of 2, there's a max of 3 terms that can be in that function. Now we can have unlimited. So, say we have 3x squared, or 3x cubed plus 2x squared minus x. Were you raising your hand?
No, I was fixing my hair.
Oh, okay. 3x cubed plus 2x squared minus x minus 7. And we have x cubed minus 10 x squared and then plus 8. And we want to add these together. Okay?
Do you just add like terms?
We
or
just
do you have
combine
to...
like terms, absolutely.
Ah.
So if we wanted to do it horizontally like this, we would just like find the terms that are like. So we have 4x cubeds, we have negative 8x squareds, and then we have negative x and negative 7 plus 8. Or we could do it vertically and line them up like we were doing when we were doing linear combination. Minus x minus 7, and then x cubed minus 10x squared plus 8. I'm skipping over this x because there is no single x term.
Where do you know where to break it? Like, you kind of, like, broke it at the plus sign there and brought it under for the vertical.
Because those are the 2 separate polynomials.
Oh, they're like in standard form. Okay.
Yes.
So you just break it where standard form repeats. And then,
Like this.
Yeah.
And like this. These are the 2 polynomials we're using. So now here I'm lining it up by degree so I can combine all my like terms, and I'm still going to get the exact same answer. So it doesn't really matter which way that you do it. Does that make sense?
Mm-hmm.
Okay. So that's adding. The exact same rules apply to subtracting. You're just combining like terms.
Yay! It's not the slashy, crossy, weird things. You don't have to do any, like, fancy stuff, like with the... Never mind. I'm good.
Okay. Good. Okay, so they also give you multiplying polynomials vertically, which you can do if you want to. I've gotten pretty far in my math career without ever having done that. So, up to you. If you would like to do it vertically, have at it. If you would like to do it horizontally, which is pretty much just distributing, good to go. That's the way I've always done it. Okay, so I don't really want to spend any time going over the vertical one.
The multiplying thing?
Mm-hmm.
Is that what we're looking at? Okay,
So,
I thought we were still talking about subtraction for some reason.
I'm referencing example 3 on page 338.
Yeah.
Mm-hmm.
Yeah, if you would like to do it that way, you are more than welcome to.
That just looks confusing. Like,
Yeah, I think it's
example
pointless.
4 looks
And
way
so
better.
I'm just going to go with example 4 because I've been pretty successful using this method. Okay, so we have x minus 3 times 3x squared minus 2x minus 4. Okay, so it's really important as you guys are doing this not to get confused with the multiplication just because we're multiplying big things together. Multiplication is what it is. You're pretty familiar with that at this point, hopefully. Yay! Okay, so, and I say that now, and also that's going to apply in the next example that we do. Okay, so I'm just going to take this x and distribute it to every single one of these terms. So, like this. So I get 3x cubed minus 2x squared minus 4x. Then we do the same thing with the negative 3. Minus 9x squared plus 6x plus 12. Combining my like terms, I get 3x cubed minus 11x squared plus 2x plus 12. Questions? Good. Okay. So So then in example 5, we're going to be multiplying 3 binomials together. Remember that a binomial means that there are 2 terms in each one. I think this marker is dying, but I think it's one of my favorites, and I'm sad. Okay, so we have...
Never mind. I was going to ask if that was one of the ones Jacob gave to you. Or
Oh, we're in
the-
6, 3 now.
what? Sorry.
X plus 4 times X. Oh, markers!
Yes.
One of the markers. I don't think it is. Because it seems kind of older. I like the color. Okay.
It's a pretty color.
I think it's a pretty color. I like blue. Okay, so how does multiplication work? If we have 3 times 2 times 4, do we multiply 3 times 2 and then 3 times 4? No, we just multiply straight across, right?
Okay.
If you did multiply 3 times both of these, then you would have your answer be 3 times too big. So here we've got 3 things being multiplied together. So we're just going to multiply straight across.
6 squared plus
Well, yeah, we're going to multiply the first 2 together, and then we're going to take that answer and multiply it times the third.
Like normal multiplication.
Exactly. We're not going to take this x and do x times this and then x times this, because that's too many x's. Make sense?
Yeah.
Okay. So we're going to get x squared, and then plus 4x minus x minus 4. And then we're going to combine our like terms. And then we're going to multiply that times x plus 3. And it doesn't matter which order you go in, because remembering your rules of multiplication, multiplication is commutative. So you can do a times b or b times a.
Yay!
It doesn't matter. So doing it this way, I multiply x squared times each one of these, and get x cubed plus 3x squared, 3x times each one of these, plus 3x squared, plus 9x, and then negative 4 times each one of these, minus 4x, minus 12, combining my like terms, get x cubed, really huge exponent, plus 6x squared, plus 5x minus 12.
In this section, will they have us do it with anything more than binomials? It doesn't look like it.
I don't know.
We're going to do 6.4 as well today.
I'm going to do my best. Yeah. Okay. The goal is originally to finish chapter 6 by the break, so that you
By
guys
the
can do
break?
your test. Yeah.
Mm,
Obviously, we fell behind.
Just a little.
Are we still trying to get to that goal?
Well,
Depends on you guys. I can do it.
That's a lot to do.
it goes
We
up to
don't even come back- we don't even come next
6.9.
I know.
So that means
It's
we're
today
doing
and
all of
Wednesday.
it this week.
Yeah, and Wednesday we might have a little shindig.
Wait, so are we
Okay.
doing 6.3 and 6.4 is due to Wednesday?
Okay, this is what we'll do. All of your homework will still be due on January.
So all
Okay.
homework's due Monday.
So you do not have any homework due on Wednesday. Especially because there's people missing and that's what's going to happen with them. So all the homework is going to be due in January.
Don't lose it, you guys.
Yeah.
Homework trade-off, where I give you all of your graded homework
Oh.
and you give me all of your ungraded homework. And then we...
But what we only
Yeah.
have will be for Tuesday, Thursday, Friday. So the homework will only be for Tuesday, Thursday, Friday.
Yes. You know what? We're not going to finish chapter 6 because also then we wouldn't have anything to really work on when you guys come back from break. We are going to have review.
Yeah, don't we have finals?
So, but I want to get through
Yay.
6-6,
Okay.
hopefully.
So, 3, 4, 5, 6.
Yeah, I want to do 6-3 and 6-4 today, 6-5 and 6-6 on Wednesday. But none of that homework will be due until January.
Okay.
Okay.
That's not bad.
So you
so
let
we're
it a
not
math
meeting the
result.
Monday after?
What?
We're not meeting on
No,
Monday
that's-
next week?
Oh no,
Okay.
we have break.
Yay!
We just have to do
Yeah.
homework on
I'm
Tuesday,
sleeping in.
Thursday, and
Mm.
Friday, and then we have break.
I mean, I love my students. But seriously, I'll be sleeping in hot cocoa and the Santa Claus. Although I think my favorite Christmas movie is Home Alone, which is so funny. Or Just Friends. Have you ever seen Just Friends?
I haven't seen
so funny. It's very funny. It's with Ryan Reynolds and Anna Faris.
Oh, really? That sounds
Yeah.
good.
He's super fat in high school,
Oh, I think I saw that.
and he is in
comes
love
back
with his
and he's
best
all, like,
friend.
handsome.
And then they make fun of him because he tells her how he feels in her yearbook,
Mhm.
and then the yearbooks get switched. So this really popular jock guy sees it and he reads it to everybody, and they make fun of him. And he's like, "I'm leaving this town." And then he moves to LA and becomes a record producer, and he like looks like Ryan Reynolds at this point. And it's really, really, really funny.
I want to see that.
Yeah, it's super funny. Very funny. I'm thinking about it now. Okay, so now looking at this little green box, we're going to talk about special cases.
Bum, bum, bum.
Okay. Okay. Is there a green? I want to use green. Okay. So, because we're using a green box, we've already done this one, the difference of squares. So if you have a plus b times a minus b, what ends up happening when you FOIL it out is you get a squared minus ba and then plus ba. I should have done ab, I suppose. And then plus ab, or b squared.
No.
Minus b squared. So these two terms are additive inverses, so you're only left with a squared minus b squared. So anytime at all that you have to multiply, these are called conjugates because they're exactly the same thing repeated, except the only difference is the sign. Does that make sense?
Yeah.
And conjugates we have to use a lot, like we experienced with rational numbers and the imaginary numbers and all that stuff. So if you have, let's say, 3x plus the square root of 4, or no, 5, times 3x minus the square root of 5, you don't even need to FOIL it out at all, because you know that these are conjugates. So it's going to end up being 9x squared minus 5. Does that make sense? And if you see something like this, now this is not a perfect square. So when you factor it, you probably will not be asked to factor things as irrational numbers. But you'll probably only be asked to factor things like this. Perfect square, so you would know 3x minus 5 times 3x plus 5. And for binomials, the only special product is a difference of squares. And then there's also the perfect square trinomial. And that's it. Those are the only two options. So, when you have a perfect square trinomial, and I'm talking about things that factor into binomials, because there's another special product, but that doesn't factor into two binomials. Okay, and then talk about it. Okay, so if you have a plus b times a plus b, because the only difference between this situation and this situation is that the sign is the same here, these two won't cancel out, they'll just add together. So you'll end up getting this, which means that the middle term is 2 times AB. And then you'll have the squares on the outside. And this is stuff like this. If you notice that your n terms are perfect squares, you're going to square root each one of them. And if you can multiply them together and double it to get this, it's this. So the square root of 9 is 3. If 3 times 2 is 6, then it factors like this. That make sense?
Mm-hmm.
Now, if you had a coefficient here, like say you have 25x squared plus, let's see, 15x, or no, 30x. 30x plus 9. If you notice that the outside terms are perfect squares, what's the square root of 9?
3.
What's the square root of 25?
5.
So what's 3 times 5?
15.
Is this 15 times 2?
Mm-hmm.
Yep. Perfect
What?
square.
Wow.
What?
Cool.
Okay, wait. How did you do that again? So,
I'm a
square
little
root
bit
of
confused
9,
about the
Yes.
30 part.
Okay, so what's the square root of 9?
3,
Oh, it's the yeah.
3.
Okay, I got it.
And what's the square root of 25?
5.
5. If we multiply that times 2 and we get this middle term, then it's a perfect square.
And then you got the 5 from the square root of 25.
Right.
So-
Ordinarily, you've only worked with these, where the coefficient of the first term is just 1, so you don't even have to think about it. But it still works.
The square root of A
Squared.
times X plus the square root of C, and all of
Oh, I
that
see what you're
squared
saying. Okay, yes.
is the answer.
Not squared, but yes.
Right, because, well,
Oh,
squared
yes, I
because
see what you're
it's
saying.
like on
Okay.
the outside, yeah. Quantity squared.
There you go. Does that make sense? Excellent.
Yes.
Okay, so now let's talk about something that we haven't done in our class yet. You might have done it in Algebra 1. I don't know.
I hope.
Okay, so something happening in football right now?
In football?
Yeah, my brother just texted me. He only talks to me about football and baseball.
Not that I know of.
I think Jacob would be the only person who would know. Do you know sports stuff?
I mean, I watch football and I kind of keep up with it, like somewhat, but I don't know.
Kinda.
Oh, Tani. Do you know who that is? I don't know who that is either.
How do you spell it?
Ohtani. Oh, Tani.
They had the Heisman on Saturday. I know that.
Who won the Heisman?
I don't know who won. I watched part. I watched like most of it. I didn't know. I was doing
Saturday
homework.
was my sister's birthday party, and it was a social thing. And I don't seem introverted, but I'm so introverted that when I was sitting at the table with a bunch of people, I looked at my thumbs, and I was like,
Okay.
wow, thumbs. And then at a certain point, I was like, everyone's distracted, and I went in my mom's room and sat on the floor and played games on my phone until they found me. Made me come out. I hate interacting with a bunch of people. I can't stand it. It makes me so like, ah!
Okay, so
I'm not a crowds person.
Yeah, I'm not a crowds person. Okay.
wait,
okay
I'm a little
with
confused. So there was an
people,
article
but
posted by NBC Sports about 2 hours ago about this dude. I can't focus long enough to read this. It's just boring.
Who won?
I don't know. It's
The
just
Baltimore Orioles did not try to get Shohei Ohtani
I know it
on
was.
principal.
a little bit
Okay,
confused.
so it's baseball.
It was
Yeah.
Baker Mayfield. What's it? I
35
forgot the other guy's name. It was Lamar something. And then
Japanese players. Oh, okay. So he's a Japanese player.
Oh.
That's-
is that the
that's
guy
not
who's
him.
been like kind of controversial in Japan or something? Like he went from a Japanese league to an American league. I think there was something about that.
Recently?
for what?
Baseball?
For baseball?
Yeah.
We're talking about baseball?
Okay.
I'm talking about football.
No, it's baseball.
I wasn't sure. Let's see.
Yeah, I thought they had the Heisman.
we need to have a little
That's
respite.
football.
Yeah, I want to know about the Heisman too.
Ooh.
Can I run to the restroom while you guys are looking it up?
Yes.
I
Heisman.
think Mayfield might have won it.
I'm
December
very
10th.
confused at this moment.
Baker Mayfield.
Oh, he did?
Yeah.
That's what I thought. Because he was in the running. It was Baker Mayfield, some other dude, and I forgot the guy's name. But it was sounding like Baker Mayfield was going to.
Huh. Okay. I'm not super whatever. Okay. Shohei Ohtani. Oh, my brother spelled his name wrong. Oh no. Google spelled his name wrong. Japanese professional baseball pitcher. Oh my gosh, an outfielder. He's a pitcher and an outfielder for the Los Angeles Angels.
Yay!
Oh, whoa.
Salary 270 million Japanese yen. So who knows
Okay,
how much
so-
that is in dollars.
Okay.
It's probably like $2.7 million.
Probably.
He's a pitcher. He's left-handed. He's 6'4" and Japanese. Whoa.
Miracles can happen.
Beast.
The Japanese Babe Ruth.
I think that's $2.7 million.
It's probably about that.
Okay. Let me look this up.
That's like you either need to be like a kicker on a football team or a pitcher.
I'm gonna look at his stats. How come everybody on Google spells his name wrong? I can't believe he's 6'4". That's crazy.
That's insane.
He has officially recorded the fastest pitch by a Japanese pitcher at 102.5 miles per hour. Wow. He also set the record for fastest pitch by a Japanese high school pitcher. He received interest from numerous teams, including the Rangers, Red Sox, of course the Yankees, and Los Angeles Dodgers. He announced he would pursue a career in Major League Baseball rather than turn professional in Japan. He would sign with the Fighters.
Yeah. 2.37 million.
Let's see. Wow, he has a really good batting average for a pitcher. It's 332.
Oh.
He's a pitcher?
Yeah. Wow.
Cool. Sports.
On December 8th, he signed with the Angels, and the deal was finalized the next day.
Well, maybe
Cool.
the Angels will be good again.
Probably.
They've always been good in my heart. Okay.
Yes, but be good to the rest of the world.
Yes. Yeah. I love the Angels. I'm a big fan. Big fan.
Big fan.
Okay.
It's the new Babe Ruth.
He's probably not.
I don't. Yeah, no.
I don't know what the heck, but players back in the day, they were really good. Okay.
It's all the drugs these days. It's ruining the players. I don't know.
Talking about these two bad boys. Okay.
That was
So,
fun.
No.
if you have x plus 1 times x squared minus x plus 1, what happens? Well, let's find out. Spoiler, I already know.
Yay.
X cubed minus x squared, right? We haven't gotten very far. I just this.
Big sports stuff.
So x cubed, right, minus x squared plus x, and then plus x squared, because of this, and then minus x, and then plus 1. So negative x squared, positive x, negative x, x cubed plus 1.
Hey. That's pretty cool. Bunch of stuff.
Yeah. Cool. And so what if we switch the signs? What if we had x minus 1 times x squared plus x plus 1? What would happen? Well, we would get x cubed, and then plus x squared plus x, and then we get minus x squared minus x plus 1, or minus 1. Because negative 1 times positive 1. Oh, positive x squared, positive x, negative x, x squared minus, or x cubed minus 1. Make sense?
Mm-hmm.
Now, the algebra makes sense, or the funny thing Justin said makes sense?
No, this
I
makes
didn't say
sense.
anything. I just chewed really loud.
Yeah. It's
I heard you
annoying.
say you're welcome.
Or chewing really loudly because he likes to annoy everyone.
Does this make sense? Okay,
Yes.
so this is just going to be memorization of this pattern. When you see this, because you can FOIL this out and simplify it. You don't have to memorize that. But when you see these, they factor like this. If it's a cubed plus b cubed, the first term is a plus b.
Cute.
And then, nope,
No?
because it has to look like
A
this.
plus B.
And then it's going to be a squared minus ab plus b squared. And if you have a cubed minus b cubed, the first term is a minus b, and then it's a squared plus ab plus b squared. Good? So this is going to be memorization. It's not that bad. I mean, it's
Are those patterns in the book?
Yeah.
Yep.
Where do they show them? Okay. 339, I think.
Oh, they're doing something different. Darn it.
Dang, darn.
Oh well, this is still important to know. This is 6-4, so I'll just do what they did too. I wish they hadn't given this to you there because there's a trick that you guys haven't learned. Have you ever heard of Pascal's triangle?
I've heard of it. I don't remember what it is.
I'll show you what it is.
I think I might have done it last year.
Anybody need this?
Or maybe another one.
That would have been like overwhelmingly a thorough class.
I had a tutor for most of it, so maybe she taught it to me.
I would never teach an Algebra 1 student Pascal's triangle. Personally.
Alright, no. I had a tutor for most of geometry. What am I talking about?
Okay.
1 year.
Right? What is 1 plus 1?
2.
Okay. What is 2 plus 1?
4. Well, 2 plus 1, sorry, 3.
Where are you living?
Nowhere.
What is 2 plus 1?
I'm not going to try for this one.
3. I'm surrounded by ones. Okay. What is 1 plus 3?
6.
4. What is 3 times 3? Or not times, I meant plus. I'm sorry. 3 plus 3.
6.
And what is 3 plus 1?
4.
Surrounded
You
by
gotta really
ones.
think about that.
1 plus 4?
5.
4 plus 6?
10.
6 plus 4?
10.
4 plus 1?
5.
Okay. Do you see the pattern of how I'm getting every row?
Yes.
Like this? That makes sense?
Yes.
These are the coefficients for any binomial expanded out to the relevant power. So, this is the, if you have a plus b to the n, okay? This is to the 0 power, this is to the first power, this is to the second power. Remember we talked about, like if you have a plus b squared, then it's a squared plus 2ab plus b squared. What are the coefficients over
1,
here?
2, 1.
That was really loud.
What?
So,
That's so cool.
there
I've
are...
never thought math is cool.
Yay! Awesome! So,
Grade bump for you.
you can draw out Pascal's triangle to the infinite. You can keep going, and it will always work as the expansion of a binomial.
Because you can have a plus b to the 200 and still get all
It would still work. It would take you a really long time.
the...
But, so if you have
There's got to be something on the internet to save you that time.
a plus b cubed, okay? This is the second power. This is the third power. So, the only thing you guys are going to need to remember that you have not is, okay. Right here, the degree is 2, right? Because this was the degree. But the degree of b is 0. And then here, a goes down 1, b goes up 1. And then here, a goes down another 1, and b goes up another 1. Does that make sense?
No.
A squared is equal to a squared b to the 0. Right?
Yes.
Okay.
B squared is equal to b squared a to the 0.
Yes.
So, when you're expanding out your binomial, the two terms that are in here will be raised to their highest powers on either end. B counts up 1 or down 1 going this way, up 1 going this way. A counts down 1 going this way each time. And every single term, if you add the degrees together, it will be 2. Because this was 2.
So it's like a squared, a to the 1, a to the 0, and then b squared, b to the 1, b to the 0.
Yes.
Gotcha.
So expanding out a plus b to the third. My first term, every single term has to add up to 3. But then my next coefficient is 3. A goes down 1, b goes up 1. Make sense? My next coefficient is a 3. A goes down another 1, b goes up another 1. my last coefficient is 1, A goes down again and B goes up again. It's just a pattern. Do you want me to keep going? Because the book only goes up to 3. But I can. So, like, A plus B to the 4th. You know you're going to have A to the 4th is your first term, plus 4 A cubed B to the 1st, plus 6 A squared B squared, plus 4 A to the 1st B cubed, plus 1 B to the 4th. And if you look, 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4. Make sense? Cool. There are other ways to find these coefficients. There's a thing called the binomial theorem. I don't think you guys, I'm not sure if you do that until the very, very end. But now you know.
This is called
Pascal's triangle.
triangle.
Yeah. You know, like the name of the chameleon in Tangled?
Yeah.
Pascal's triangle. Pascal is a cool guy. Came up with all kinds of things. Yay. Okay. So that's it for 6-3. 6-4! Yeah! On a roll. We already did the first part of 6-4, so we're almost done.
Yay.
Okay. Is 6-4 like small, kind of just accompany 6-3?
Yeah, 3 and 6-4 go together. Okay. Well, now we're talking about factoring. That's really all we're doing.
This is going to be painful.
It's not going to be that bad. Okay, eyes up here. I'm going to make it not so bad. Okay, so we already talked about if you have A cubed plus B cubed, right? That equals A plus B times A squared plus AB plus B squared. You guys are good with this?
Mm-hmm.
Okay, so if they tell you, if you have like a cube, what's the thing they give you? I don't want to do that example, it's really dumb. Okay. Yeah. This is, forget it. No cube. Pi cube. Okay. Okay. So, there are some patterns to factoring. If what you're trying to factor only has 2 terms. Okay, so if you're trying to factor a binomial, so a binomial, it can only be factored in one of 2 ways, and that's it. There are only 2 options. There could be a GCF, or it's a special product.
Special products, are those all the things that we were doing in
Those are the ones with the
6-3?
patterns.
Yeah, okay.
So, yeah, that's going to be difference of cubes, sum of cubes, difference of squares. That's it. The only options. Okay? If it's a trinomial, you're going to factor it using the X method. You guys remember that, right?
Yes.
Where you get A times C and B, and then what multiplies to AC but adds to B, and put those here.
Okay.
So that would be like,
That's right, I forgot about that.
if it's a polynomial with 4 terms,
What's that called? Like a...
it doesn't have a
Quartic?
special name.
Oh, no, it's not.
Because a quartic has a degree of 4.
Oh, okay.
So, polynomial with 4 terms, you're going to factor by grouping. Have you guys done that yet? I don't remember.
Don't think so.
Okay. So, factoring by grouping, is like this. X cubed minus 2x squared minus 9x plus 18. Okay, if it has 4 terms, you can't really factor it. So what we're going to do is split it up into 2 binomials. So we can factor binomials like this. So, first thing you always should check for is there a GCF? So is there a GCF between x cubed and negative 2x squared? Do you guys remember what GCF stands for?
Greatest common factor.
Is there a term that we can divide out of both of these evenly?
X squared.
Absolutely.
Oh, okay.
You get x minus 2, right? Yeah. What about this one?
9.
Yeah, let's take out a negative 9, so we always
Okay.
want our first term to be positive. So, minus 9, and we'll be left with x plus 2. Whoa, hey now, we have another GCF. So let's pull that out. Oh, that was a minus.
Yeah.
And we'll be left with x squared minus 9. Do you recognize this?
Is that one of the patterns?
It's one of the patterns. Perfect square, perfect square.
Oh.
So it factors into conjugates. Now, nothing else can be factored, that's it.
Okay.
Does that make sense? And there we go.
Yay.
This is important. Do you guys need to take notes or anything on that? Because this is how to factor each time. I will expect you guys to know how to factor by how many terms there are.
Wait a second. This is all.
This is not in the book.
This is not in the book.
This is me teaching you.
Okay.
I want some tomatoes.
You want tomatoes?
Yeah, have
Grilled tomatoes sounds so good.
some. Ugh,
Do you not like grilled tomatoes?
not really.
I hate any kind of warm vegetables.
Oh, I
Like,
love warm vegetables.
Who wants to eat warm vegetables? Like,
I like
the point
steamed
of vegetables
vegetables.
is to be fresh.
But roasted tomatoes, they just, or not roasted tomatoes, those are good.
Yeah.
But grilled tomatoes just get so mushy, and the skin doesn't.
Well, I don't know. I grew
I'm gonna
up
take a
eating
picture
them.
of this and then.
Okay.
My grandma cuts up like big tomatoes and puts sugar on top of it, and we eat it as like a fruit because she's weird in Korean.
Oh, we
She's
put
weird
salt
in
on it.
Korean.
Yeah.
Understandable.
And you know, it is a fruit technically, but like, you know.
Yeah.
You don't eat it like a fruit. Unless you're my grandmother.
My phone is breaking.
Right.
It always is.
Aren't you giving the X?
I want to.
Wait, so when do the classes start later?
Well,
So-
it's just
Should I not expect my 12:30 class until 1?
probably they won't be here until 1 unless they come early. Well, you could tell them to come at their regular time because it's not they're not really doing anything. They're just extending lunch 30
Yeah.
minutes. They're not like doing a show or like a party. It's just they're.
I think last
extending-
year they did a show, but
Oh well,
I
you
don't think
could
this
if
year.
like it's a
Nobody's
smaller
getting
class,
part of
you
the
can
show.
tell them just tell them that class is starting at 12:30.
I think it was the talent show, wasn't it? Did they already have that this year?
I think they did.
Really?
I'm going to
Yes.
sing Christmas carols in my last class
Yay.
and watch Aladdin and eat cookies.
I'm jealous. Aladdin's a good movie.
Oh.
Okay, everybody got this?
Mhm.
Yes.
The last thing we're going to talk about with factoring is still recognizing one of those 3 things.
You're welcome. Again.
What is this? How many terms are there?
2.
So it's a
Binomial.
binomial. How can it be factored? In one of 2 ways. What's the first way?
Greatest common factor.
Yeah, the thing I just erased. Right.
Yeah.
Greatest common factor. Is there one?
No.
No. So is it a special product?
Yes.
What is it?
I don't know.
Is x to the fourth a perfect cube?
No.
No. So then it would have to be a difference of squares or it's nothing. Right?
Okay.
Can we square root x to the fourth?
Yeah.
What will we get?
X to the 2. Right?
X squared, not x to the 2.
Because I'm doing it the way I want, so I'm going to say x to the 2.
What is the square root of 81? Is 81 a perfect square?
Yeah.
9, right?
Oh, I get it.
Wait, what?
Because it's
Square root of this and the square root of this. Conjugates.
it's all that good stuff.
It's difference of squares.
Where did the subtraction go?
This is a difference of squares. We went over this.
Okay, so
Like
I
we
don't know
have,
how to explain it.
here we go.
I
Oh.
don't understand.
here we go. We have another one right here.
Okay.
Perfect
Right,
square.
so-
Perfect square. X minus 3, x plus 3. Still times x squared plus 9.
So if you multiply those two together, you're going to get x4,
X to the fourth.
x to the 4th
Yes.
minus 8. Right, because it'd be 9 times 9, negative 9. Gives you negative. Wow. Nice job, Justin. You figured out basic algebra.
I miss Samantha.
I just realized somebody smudged a smiling face in the window.
It's so depressing.
Depressing.
Okay.
I'll be praying for you. 4.
Yes, you should always check for GCF first. That's your
Yeah.
first step for every single factoring. 4x squared, right? Because there's at least
Oh,
one
yeah.
square.
Yes.
All of those.
So if we
That thing.
factor that out
X cubed.
to the fourth, remember if they're being if the bases are being multiplied, you add the exponents.
Okay. Got it.
So x to the fourth minus 5x squared plus 6.
Got it.
Okay. If it's 3 terms, how can you factor?
Using
What
the
was it called?
Mm-hmm.
X thing. I don't know what it's called, but it's
X
just
method. Do we know
Yeah.
2 numbers that multiply to 6 and add to negative 5?
6 and 1.
Adds to 7.
3 and 2.
3 and 2.
You're a genius.
Heyo.
So even though this is x to the fourth, I can still treat it like a quadratic. I'm just gonna, because I know that they added to x squared and they multiplied to x to the fourth. So it must be x squared.
Yeah.
Yes.
Yeah.
Okay.
Does that make sense?
Oh,
Yes.
right. So it'd be negative 3 times negative 2.
Yes.
Good? Good. The last thing is a combination of what we've done before and what we just learned. If you
Okay.
have, there's so much super light. No.
Ta-da.
Ta-da! Yay! Yay! If you have this, and you're supposed to solve. Okay, let's get all of our x's together. So you 2x to the fifth minus 14x cubed plus 24x equals 0. Do you notice something about all of these terms?
They're even.
They're even.
Yes. So does that mean, what does that mean?
You can divide by 2 at least, right?
2x.
2x.
Okay.
Now, if this were just a 2, we could completely get rid of it because we could divide both sides by 2.
Mm-hmm.
If you divide both sides by 2x, it will change the degree of this polynomial. It will go from being a 5th to a 4th, and that's bad.
Okay.
Because remember, there's a big difference between a polynomial that has an odd degree and a polynomial that has an even degree. So, we can divide out the 2 from both sides, that's fine. Bye. But not the x. Okay? So, how many terms is this?
3.
Can we factor it?
Yes.
How do we factor? With 3 terms.
The x.
X method. Do we know of 2 numbers that multiply to 12 and add to -7?
-4, -3.
Absolutely.
Oh, nice.
So this becomes x times x squared, because this is the 4th, so it multiplies to the 4th but adds to the 2nd, minus 4 times x squared minus 3 equals 0. Okay. Do you notice anything about this one?
Mm-hmm.
What?
It's a perfect square. So you can,
It's a difference of squares.
difference of square. Okay.
Right. So it factors how?
X plus 2 and x minus 2.
Absolutely. Very good.
Nice.
Can this be factored?
No.
Right. So now we're going to use the zero product property. All of these things are being multiplied together. Their answer is 0. Any single one of these being 0 makes this true. When we're dealing with equation, the only thing that matters is that it's true. So, if x, what would x have to be in order for this to be 0?
0.
Exactly.
Oh.
What would x have to be in order for this to be 0?
-2.
And this one?
2.
And this one? Just imagine in your mind.
Right.
Okay.
When did we learn zero product property? Was I like not here for this?
No, it was when we did factoring the first time.
Okay. So it was a little while ago.
So,
I don't remember being able to have so many answers for x.
well, we've never had that before because now we're dealing with polynomials where you have a higher degree. Before you would only have 2, but I did tell you at the time, if you have x squared, you will have 2 answers.
Was this when we were still in the closet?
Mhm.
I think I remember it.
So now we have x to the 5th. So how many answers should we have?
5.
1, 2, 3, 4, 5.
Oh, got it. When you said
Cool.
when we were in the closet, it makes it seem like
We were gay.
yeah. Yeah.
That's okay.
When we were in the closet.
No, we're not.
Does this make sense?
Yes.
Okay. I think that's everything.
What's
Coming
the
out
homework?
club.
Coming out. Welcome to the Coming Out Algebra 2 class.